I'm going to run through this really quick. We'll be talking through security principles for designing cross-chain messaging protocol. So we often see multi-chain, cross-chain, omni-chain. What are the differences between those three? Oftentimes when we're saying multi-chain, we're thinking about isolated instances of your protocol deployed to multiple chains. For cross-chain, it's actual value transfer between different chains, so that could be through a wrapped asset bridge, it could be through arbitrary message passing, many different implementations. And then omni-chain is this sort of concept of mesh network and actually enabling seamless movement of assets and information, essentially arbitrary contract invocation between chains. And why is this important? I think everyone in this room understands the security risks, and we'll run through that in a second, but also the user experience and developer experience involved. For me, when I first got into the space, I started as a developer at Layer 0 and thought about different chains like different programming languages. You would never think to yourself, what can I build with C++? You would think, I have this problem that I want to solve, and here's the product I'm going to build. What are the tools at my disposal to build that? And so with the piping underneath the hood, which is a cross-chain messaging protocol, you can now leverage the best of ZK Sync or Linea or Polygon ZK VM, and then also Filecoin VM for storage, pull in liquidity from Ethereum, and maybe launch your own app chain for sovereignty and to avoid gas congestion for maybe the game that you're building in that subnet or supernet. What is Layer 0? I'm head of strategy at Layer 0 Labs. We are the creator of Layer 0, the protocol, an omni-chain interoperability protocol, and Stargate Finance, which is the most widely used native asset bridge. It's arbitrary contract invocation, and our protocol architecture and design is very particular to these three principles I'll walk through, and also the concept of evolving with research. So these three principles are immutability, permissionlessness, and censorship resistance. This right here is the architecture of Layer 0, which may be useful later, but I think it also might be hard for you guys to see it. So I'll dive right into the first principle, which is immutability. When I say immutable, what I mean is the contracts. Are they upgradable or non-upgradable? And the issues with mutability or upgradable smart contracts are that when you push code to, let's say, the core contracts for your bridge, you, one, are actually resetting the security that has been locked and secured all over time, but also pushing existential risk for all of the projects that have built on top of your bridge, integrated it, and all the users who might hold assets from that as well. In the same way that, and I was speaking on a bridges panel earlier today and used this metaphor, if your Trezor or Ledger were to push an upgrade and you saw that, you would likely reject it, or it would give you a lot of pause. Why would you accept the same for your DeFi protocol? And for many cross-chain messaging protocols, they do use upgradable smart contracts. And so even if a developer is introducing a benign patch or is trying to introduce a new feature with good intentions, the chances that there's a smart contract bug in that, which all of the applications built on top did not opt into, is incredibly high. In fact, the majority of bridge hacks over the last 2 years were because of smart contract upgrades, not because of architectural flaws. So, even great and well-meaning developers make mistakes. We all know this. This is a graph that demonstrates what I meant by resetting security. When you upgrade the protocol, it resets the perceived security over time, which is measured by value secured in time. And where you see that blue bar is the upgrade to the smart contract. How can you design a protocol that enables applications to opt in to the smart contracts that they've vetted and have seen secure value over time, but also have optionality? Because let's say the validation techniques we use today will not and likely should not be the ones that we use 5 to 10 years from now. How can you offer that without doing a complete overhaul of your protocol? And that's exactly what the architecture I may have time to walk you through achieves. And here it is, a solution, library upgrades. So how we designed Layer 0, the protocol, was by deploying endpoints on each of the chains which we support, and these endpoints are entirely comprised of immutable smart contracts. However, we can always launch new endpoints, and applications can point their contracts towards those. That means we could launch a smart contract library, which are the endpoints that leverages ZK technology or some new validation technique in the future. In between all of these endpoints are the off-chain entities that are involved in validating separate components of the state data. And as you can see here, it doesn't reset the security clock. There is no forced upgrade. It's always opt-in for applications, and it allows for time and money secured to reach a threshold that is acceptable before applications opt in. The second principle is permissionlessness. We talk about this a lot in many different contexts. In the context of cross-chain messaging, what I'm referring to is the ability for a developer to leverage your protocol in whichever way they'd like. And in the case of Layer 0, we are open and permissionless, and application devs can use it to create something that we might not align with from an ethos perspective, but there's nothing we can do as Layer 0 labs to interfere. It also means that participation, the validation, and network is also open and permissionless. So if you'd like to run one of those components yourself, the oracle, the relayer, multiple oracles, multiple relayers, you can, and it doesn't require any coordination with Layer 0 labs. This also enables and encourages client diversity, since maybe you have a set of 20 validators and you're requiring 13 of them to agree, but all of those validators use the same code. Ultimately, that client diversity is one. By leveraging different oracles and relayers provided and run by, say, like Chainlink, Blockdaemon, Gelato, Layer 0 Labs, your own team, you have that client diversity, the optionality, but also the backstop if your team were to run one of those yourself without unilateral control or centralization. And this also leans into the dichotomy between protocol and service. So when I say service, I mean a product which requires the creator company to maintain its integrity and liveness and the actual value it's meant to provide. A protocol is something that is evergreen. It's a primitive, it's immutable. You can use it as you like. And when you're choosing these really important parts of your infrastructure stack, you don't want to be, one, adding more code exposure, but two, relying on a founding team that might get arrested, which happened recently with multi-chain, or a team that may run out of runway and actually just shut operations down. Or a team that needs to constantly be patching code. So without immutability, permissionlessness is never guaranteed. And the final principle is censorship resistance. We talk about this a lot in different contexts, but in the case of bridging and cross-chain messaging, it's actually even more important, in my opinion. If you have the ability to reorder messages as they're submitted, that means that a high-frequency trading firm could extract more MEV, for example, by reordering messages and front-running. It means that if a nation state were to leverage cross-chain messaging or just blockchain technology for voting, it would be possible to possibly censor a tranche of those votes. Layer 0 is designed to be non-sorter enforced, and so every message must pass across the protocol if validated properly in the order in which they were submitted. And so, like I said, cannot reorder delivery of messages or censor individual messages, and applications can also always choose different off-chain infrastructure by swapping in and out. And again, without immutability, censorship resistance is not guaranteed. I have about 2 minutes left. These two graphs just show the growth of contracts that are building cross-chain, omni-chain, multi-chain. These specifically are contracts that have integrated Layer 0 in some capacity. So on the left-hand side is testnet, right-hand is mainnet. This is back from April, and it has continued to steep up and to the right. So it's actually just really exciting to see what's going to be coming out over the next few months. We're seeing, and I personally have been involved in traveling the world to be in person with teams building omni-chain stablecoins. Tokenized T-bills, for example, that will be native on multiple chains and seamless transfer between them, leveraging Layer 0. Games that under the hood are leveraging ZK Sync and a Polygon Supernet and Ethereum, but abstracted away so the end user is just playing a game. There is no tribalistic affinity of it's a Solana game or a Polygon game, and they use one gas token and do one click in order to move their in-game assets between chains. We're seeing NFT projects moving between chains as well. TradFi, leveraging cross-chain messaging to communicate from permission chain to public chain. And then, of course, across all of DeFi, there are so many interesting things happening with LSDs and also lending and borrowing from one chain to another. Lend in one chain, borrow across 5 different ones, collapse it into one click, and use one gas token. So it makes me incredibly excited for the next year, the next 5 years, since some of these projects take a really long time to develop. And security really is at the forefront of this. It's unfortunate that nearly every single month there's some sort of hack, but it comes down to the violation of these three principles, and something that I encourage all the developers in the room to think about. So I have 20 seconds left. I want to thank you all for helping me with my Wi-Fi and being super patient. Really nice meeting you all, and happy to answer questions.
Irene, there's one question. We have time for questions.
God, I hope it's not a dumb question. Hi. I was wondering if you could explain a little bit more about pre-crime, because that sounded technically really interesting. And yeah, I know there's quite a few experiments going on around in the ecosystem with local forks, simulations, etc. And so this is really cool because it sounds like it's something that's actually used in prod.
Thanks for the question. I'm being instructed to come back on stage. Yeah, so pre-crime is a proprietary security module that we created actually prior to the launch of Stargate, which is the native asset bridge that came out about a month after Layer 0, the protocol, went live last March. And what pre-crime does is it forks every message that goes across the protocol and tests it locally against a set of invariants that are defined by the application. And so that could be a formula that helps prevent the double spend issue. It could be a set of whitelisted addresses for an NFT migration. It can be quite literally anything the application developer wants it to be. And only then will the message be pushed back to mainnet and run across the protocol. And the idea of it is stop a hack before it happens. And the efficacy of monitoring once that hack is actually happening is as ineffective as a Twitter thread saying $100 million has been withdrawn from this bridge. The auditor sitting to my right on the panel earlier today was talking about that. And pre-crime is meant to solve that issue. No, but actually, interestingly, right now, pre-crime is only opt-in, and it was used to protect Stargate, like I said. 2 weeks after Stargate launched, it reached 4.4 billion in organic TVL, which was astounding. It was the fastest growing DeFi protocol of all time in that respect. Since then, we have made the protocol so much more efficient, and we haven't actually even reached peak efficiency, which would involve, I think, around 200 million of protocol-owned liquidity instead of needing external LPs. But I remember, all of our devs were at the time in the Bahamas and just saw every single black hat attacker try and break Stargate, and we built pre-crime just for it. What we're doing right now, and we'll launch in Q4, hopefully sooner rather than later, is we're scaling pre-crime, as we say, like to infinity. So every project, all of those 6,000 contracts on mainnet, can leverage pre-crime. Right now, it's not at scale to be both fast enough and to be fast enough and support all of these contracts.